So you probably saw the thumbnail for this video and going, what the heck is this and what does it have to do with circular motion? So I hopefully can simplify that for you. An amusement park ride consists of a large cylinder, rotates around a vertical axis. So the vertical axis just means it's like, here's the axis of rotation here. If the cylinder was rotating, it'd be kind of rotating outside of the page. Okay, so it's still horizontal circular motion, but the axis just happens to be vertically right through the center. So don't confuse that with a horizontal circle problem. People stand on a ledge on the inside, and so that's the best picture I could find for people. So it's an X-ray machine. Okay, there they are standing on the ledge on the inside. When the rotational speed is high enough, the ledge drops away and people stick to the wall. If the period of rotation is 3.1 seconds, the radius is 4.5 meters, what's the minimum coefficient of friction required to keep the riders from sliding down? And hopefully we'll get an answer of 0.53 or somewhere around there. It seems really complicated at first. Mathematically, it's quite easy. The biggest problem you'll have is just remembering where to start. And I'll show you right now. This talks about friction and centripetal force, frictional force and centripetal force and normal force. All that stuff kind of comes into play. So we've got our centripetal force acting that way, okay, towards the center of rotation, always. Now looking at just the person along the wall, that is also what would be called a normal force, a force perpendicular to a surface. If the bottom part drops away and it's just friction holding that person up, well, gravity always pulls down. There's our force of gravity pulling down. So the force of friction is acting upwards like this. So the force of friction has to be the same magnitude as gravity, and the normal force has to be the same magnitude as the centripetal force. So therein lies the formula. Start with what we worked with before. Centripetal force, force of friction. I'll write that a little clearer. We used to have, or we always would use, force of friction equals the coefficient times the normal force. So any friction problem can probably be started like that. But now, substitute the relationships that we have in the diagram. The force of friction has to be the same as the magnitude as the weight, mg. Normal force, I'm just going to write it in terms of forces for the moment, and then I'll put the formulas in. The force of friction has to be the same magnitude as the force of gravity. The normal force is the same in magnitude as centripetal force, because that's the force going around a circle. So now we put in the formulas for each of those. Force of gravity is mg. Centripetal force, mv squared over r. Okay. There's no information given about velocity, but take a look at your equation sheet in your handbook. Velocity is 2 pi r divided by t. 2 pi times the radius, give you the circumference, t is the time it takes to go around the circumference, and that information we're given. So we can calculate the velocity pretty easily. And that's all the information you need to solve this problem. So I'll just kind of write things a little clearer. mg equals mu mv squared over r. The mass divides out, which is why the mass is not even given in the problem. You don't need it. So the centripetal acceleration times the coefficient of friction has to be that of the acceleration of gravity. So g equals mu v squared r. So let's calculate v real quick. 2 pi r over t. 2 pi times 4.5 radius. Period of 3.1 seconds. 2 times pi times 4.5. And then, so the top part gives you about 28.3. Divide that by 3.1 and 9.12 meters per second. That's our velocity. So we're ready to kind of solve this out. I'm going to rearrange the formula with mu. So it's g equals mu v squared over r. I'm going to solve that for mu. So it's g r over v squared equals mu. So kind of cross multiplying again, so the r comes up, multiplies gravity, divide both sides by v squared. Flip down here now. D is 9.81. Leave everything positive. R is 4.5. Speed of this thing, 9.12. And then don't forget that's squared. Working all that out, careful with your order of operations and your exponents, and you get 0.53. So the coefficient of friction between the surface and the person has to be at least kind of half, or 0.53, or this person is going to slip, fall, and meet the fiery demise. Who knows? Just